Do you think social media or flyers and papers have more of an effect on purchasing equipment for sports?
Social media.
Do you think social media or poster and flyers have more of an influence on purchasing athletic products?
Social media.
Posters and flyers have more of an influence on purchasing sports-related products.
I believe social media does.
Thank you. Do you think social media or posters and flyers have more of an influence on purchasing athletic products?
Social media.
Thank you. Do you think social media or posters and flyers have more of an influence on people purchasing sports-related equipment?
Social media.
Do you think social media or posters and flyers have more of influence on the purchasing of sports equipment?
Social media.
Posters and flyers have more of an influence on purchasing athletic products?
I would say both because in today's digital world, I think social media is really a great tool to bring in more masses together. So I think that is definitely a great way of thinking and organizing it. But also in schools, I think when people are not having access to social media, a poster or a flyer can be good.
Thank you, Miss.
My name is Lara, and this is my project for stats. The final project no one wants to do, but we're still doing it anyway because we want the 100. Guys. We have to be quiet now because Martinez is back in the room. Okay. My question is, how does the type of advertising between social media and posters and flyers affect the likelihood of athletes purchasing sports-related products? My hypothesis is there is no difference, and the proportion of athletes who purchase sports-related products or exposed to social media as posters and flyers are the same, they equal each other. My no hypothesis is there is a difference of the proportion of athletes who purchase sports-related products, and there's more people that purchase it when they're exposed to social media. Now, we're going to use the board now, because I'm educated. And the sample I have is 60. I got a random sample of 60. The group one, 1 second, need a bit of marker. The group one would be, I got a total of 33, which is for social media. And the clip for all of those will be in the video right now. For group two, it was 27 for posters and flyers. And the survey was given out to 60 random athletes. And it was asking what type of advertisement. Obviously 33 shows social media and then 27 shows poster and flyers. The variables is that what kind of advertisement they selected, which would be the variable of social media or poster and flyers. And then it will be if they bought it or not. And from the looks of it, it was 30 out of the 33, only 15 bought or purchased items. And then out of the 27, 8 purchased items. So when I get my PCAP 1, which is 15 out of 33, it would equal to approximately 0.455. And when I get my PCAP 2, it equals to 8 over 27, which is approximately 0.296. And now I have to check all my conditions, which if it was randomly selected, which it was. If all of the selections were independent of each other, which they were, nothing depends on another. And then my large counts, which is 33 times 0.0455 is approximately 15.015 equals or greater than 10, which is correct. And then 33 times 1 minus 0.455, which is approximately 17.985, which is equals or greater than 10. For my PCAP 1, which you check that off, it's correct, that condition is met. And then for the PCAP 2, you have to check that condition too. It's met because the first condition isn't met because it's 27 times 0.296, which is approximately 7.99, which is greater than or equal to 10. So it's not met, and that's the reason being that the sample is not big enough. So if it was the condition met, then it would have to be a greater sample. And then you check it again times 1 minus 0.296, and it approximately equals to 19.008, and that condition is met. But again, for this one, you would need, for the condition to be met, you would need a greater sample size, which I don't have because we're limited on resources because we're a small school. But yeah. And then you check your z and your proportion. So basically it's this equation, 0. I'm just gonna do the math, I'm not gonna explain it. If I was taller, that'd be great. 455 minus 0.296 minus 0 over the squared 0.383, 1 minus 0.383, 1 over 33 plus 1 over 27, which equals to 0.159 over, sorry, it's crooked. Can you see it? 2363 times 0.0673. That equals to 0.159 over 0.0159, approximately equals to 0.159 over 0.126, which is approximately 1.262. And for when you finally get it 1.262, you put it approximately to 0.2076. Now, thank you. That would be your p-value, approximately your p-value. So then you check your confidence interval, and then we're assuming it's a 95% confidence interval. So when it's a 95% confidence interval, it would be 0.455 minus 0.296 plus or minus 1.96 to the square root of this long equation for no reason. 0.455, 1 minus 0.455 over p cap 1, which is 33, plus 0.296 minus 0.296 over p cap 2, which is 27. And then you end up getting, you put that in the calculator. I'm not gonna put it into the calculator because I'm lazy. And you get a confidence interval of negative 0.083 to 0.401 from that equation. So after all my work and after my research, we came to the conclusion with the p-value of approximately 0.2076. We failed to reject the null hypothesis, as the 95% confidence interval and the difference in proportion is between negative 0.083 and 0.401, and then to show there's a significant difference in the proportion of athletes that purchase from getting influenced by social media rather than posting flyers. Thank you.